Hello, everyone. We are presenting our paper Quality at a Glance, which is a large-scale audit of public multilingual data sets, where we look at samples of the data and determine whether it's in the languages it claims to be. It was written by a large number of authors, collaboration between a lot of institutions. You can see the author list in the background. And without further ado, let's present it.
So we took a look at different corpora, 3 multilingual corpora and 2 monolingual corpora. They are all automatically constructed, coming from different sources, ranging from Wikipedia to ParaCrawl. And they are classified by language with tools ranging from fast text to CLD 2 or 3. There are different quantities of African languages inside this corpora, as you can see on the table. And we took a look at the quality and audited these datasets.
And what do these datasets look like? Actually, the CCAligned dataset, which is a multilingual dataset, we can see the English corpora, which is supposed to have English sentences. We could see it's a mixture of different languages, and even translating it to Oromo, we see it's giving same translation for different sentences, which actually it's a flaw there. And we can see also from English to Lingala, there are also some issues with translation in this corpus and in the parallel data set. So that's for so now going to Oscar data set. We can see Oscar is one of our monolingual data sets, and we can see here the Northern Frisian corpus has data sets which actually contains English English sentences, while the Somali data set it's not even representation of the Somali language. So we have the MC4 dataset. Also, it's also a monolingual dataset, and here we see the Inyaga dataset also have some English sentences in them, which this is not a real representation of the languages it's claimed, or the language it's claimed to collect data on. And the Luxembourgish data set also has the same issue, and this is what we try to look at in order to bring out the key information, or to point it out as regards what these data sets look like.
So now conducting the audit. For the audit, we recruited around 51 volunteers, covering about 70 languages. We took a random, we selected a sample of languages by dataset. Then for each of these languages, we took a random sample of 100 lines. We constructed an error taxonomy that we are going to see next. And then we assigned to each of the recruiters these samples. So the idea is that we prioritize lowest resource languages. So we selected at least the 10 lowest resource languages for each dataset. And we also prioritize the languages in which our volunteers were proficient. So all the ratings of these different samples were collected in a Google spreadsheet. And we repeated their ratings in order to assess interannotation agreement. We arrived at a 98% mean accuracy for Oscar, and a 66 accuracy for CCAligned, 79 for the binary ratings, so for the multilingual datasets. So for the taxonomy, we have 3 major classes. So it's correct, incorrect, or other. So when we tag a line as correct, it can be correct. It can be it's correct. It's well classified by the classifier, but it's just a single word or a very short phrase. And it's correct, but it's boilerplate. So boilerplate, although quality being just random data that's coming from forms or some automatically generated text. The second major category is incorrect. We have 3 subcategories again. So it's for the for the 3 parallel datasets, we have correct in both languages, but the translation is not correct. We have mostly wrong languages, so the languages are not correctly classified, or not a language, as we saw in the examples of how the data looks sometimes. And other is when we are not sure on how to tag that data, and maybe we need a native speaker to assess it.
Right, so now about the results. So we collected all these ratings for a subset of the languages that were contained in each corpus. And so these, in total, we covered 205 of the language-specific corpora. That is a total of roughly 22,000 sentences that we rated. We found 15 corpora of those to be 0% correct. That means they contain 0% of what they were supposed to contain. We found that the quality is worse on low resource languages, but the trend is quite noisy depending on the data set. We have details about that in the paper. And among the monolingual data sets, MC4 seemed to have the highest quality across languages, and ParaCrawl for the parallel data sets. But it has to be noted that those data sets covered different amounts of languages and also different subset of languages. We also found various language code issues that we'll go into detail later. So this is the main results table that you'll also find in the paper. For each of the data sets, we looked at how often do we find each label in the audited portion, and then we averaged this across languages. So this is the second block here. And then, so for example, for CCAligned, 29% of the audited sentences were correct on average. And then we also zoom in on the lower quality ratio portion of the data sets that had, so we count the number of languages that had exactly 0% correct sentences. So these were, for example, 7 for CCAligned and also 7 for Oscar. And then we also measured how many languages was the ratio of correct sentences less than 50%. So these were, for example, 44 of the 64 audited ones for CCAligned, or 11 of the 51 audited languages in Oscar. So I want to highlight a few of the aggregated statistics here for the error categories that we had in our taxonomy. So we found highest alignment problems where the translations and the parallel data sets contained incorrect translations for WikiMatrix and CCAligned. We found an issue with a lot of wrong language contents in MC4, so roughly 16%. And we had high amounts of non-linguistic content in CCAligned, so almost 1/3. And overall, we didn't find much offensive material, but 5% of porn in CCAligned averaged across the languages that we audited. So these numbers were averages where we weight every language that we audited equally in aggregating those statistics. But if you consider the size of the individual languages and weight them accordingly, then you get a micro average. And so that means that the quality of higher represented corpora, that means those languages with more data points have a higher weight in the average, you can see that the numbers in general go up. So that means that if you don't look specifically in those low resource portions of these multilingual corpora, then those quality issues might go unnoticed.
For the African languages that were present in this data set, 39 were audited, and out of this, 26 were parallel and 13 monolingual. The quality of the data sets also varied according to the languages that were present, and we could see that some of them were extremely small. Now, for 14 of the parallel data sets and one of the monolinguals, we saw that less than 20% of them were correct. And then for Oscar and for ParaCrawl, we saw that more of them were correct. That is, more than 80% were correct, and then contained more than 50,000 sentences. So we have languages like the Amharic and Afrikaans for the Oscar, and for the ParaCrawl, we have languages like from English to Swahili, which were all more correct in the data set.
During our dataset audit, we also found that there were multiple issues with language codes, as Julia mentioned earlier in the presentation. These can include like copied sentences being mislabeled as sign languages, ambiguous superset language codes being used when a specific language is being used in the dataset, using deprecated language codes, or simply using the incorrect version of our language code. To avoid these issues, we recommend being careful about using standardized language codes, such as the BCP 47 standard. Under this standard, there are ways to specify which script a language is being written in, which regional dialect is being used in the data set, or which variety of a language group is being used.
As recommendations, we recommend to look at sample languages, perhaps even annotated, and then also to practice data cleaning and filtering on sentence levels, and then also consider documentation, and also consider not releasing data sets that have 0% in language, and then consider use of consistent language codes. And for future work, we propose to use filtering methods, language IDing, data sheets or nutrition labels, also hand-created list of websites for low-resource languages, and better or wider evaluation of crawling pipeline.
Thank you.
Thank
Thank
you.
you.